In this video, we'll review how to factor using the difference of squares. The difference of squares is when you have a binomial where each piece is a square separated by a minus sign, hence a difference of two squares. The difference of squares, a squared minus b squared, can be factored in the following form. It is the quantity a plus b times the quantity a minus b. Now I know this is true because if I distribute, I would get a times a, which is a squared, a times negative b, which is negative ab, which will cancel the b times a, and leaves me also a b times negative b, which is b squared. I'm left with a squared minus b squared. Now I can use this format to factor the following problems. Let's take a look at them. In number 1, we have x squared minus 36. Now 36 doesn't look like a perfect square, but it is. 36 is really 6 squared. So I have x squared minus 6 squared. Using the pattern above, I can rewrite it. X squared minus 6 squared can be rethought as the quantity x plus 6 times the quantity x minus 6. Now I can do the same thing for number 2. I really do have two perfect squares separated by a minus sign. This is a difference of squares. The 9x squared can be rethought of as the quantity 3x squared and then minus 5 squared. When I rewrite this, it's going to be the quantity 3x plus 5 times the quantity 3x minus 5. Now in problem number 3, again I see two perfect squares. 16 is really 4 squared and 121 is 11 squared. Because both of these have variables, it's going to be the quantity 4x squared and minus the quantity 11y squared. When I rewrite this into the factored form, it will be 4x plus y quantity times the quantity 4x minus 11y. It should look like this. So again, if I rethink of it as what are the squares, I can then use it and just substitute it into the formula above and get my factored form. Now remember, at any point you can check your work by just distributing out the terms and see if it takes you back to where you started. A way to tip off to see a difference of squares, it has to be a subtraction and it has to have two perfect squares. Now let me give you a couple harder ones. Go ahead and try these ones, pause the video, work it out, and when you're ready, resume the video to check your answers. I'll give you a moment. Alright, hopefully you've had a chance to do it. On problem number 4, I see it's a squared minus the 10b squared, or 100b squared rather. If it's a squared minus 100b squared, I can rethink of it as the a squared minus the quantity 10b squared. So I'm really looking at the a plus 10b and a times a minus 10b. Now number 2 down here, which would be number 5, if I'd actually number correctly, I'm looking at 9 squared minus x squared. Now in this case it's written in the other order. Usually the x squared's first, but that just means when we write it, we're just going to put the 9 piece in the front and the x in the back. So this would be the quantity 9 plus x times the quantity 9 minus x. Looking at it, if I distributed, the 9 times 9 is where I get the 81, the negative 9x and the positive 9x cancel, and x times negative x giving me my negative x squared that I needed. Now number 3 doesn't look like a perfect or a difference of squares because 50 is not a perfect square and 2 is not a perfect square. But I recognize that both of those are a common factor. I can start this problem by factoring out the 2. In which case I get 2 times the quantity x squared minus 25. Now that is a difference of squares. This would be 2 times the quantity x squared minus 5 squared. Which leaves me with 2 times the quantity x plus 5 times the quantity x minus 5. Because I factored out the GCF, the greatest common factor of 2, I need to rewrite it each time. Alright, hopefully this video helped you understand how to do difference of squares, and thank you for watching.